How many of you have animals in your operation? Your cows are. Okay, so we got some. How many are corn and soybean, predominantly? Okay. How many university agency people are here? Okay. And how many are here for free lunch? No, that's what I thought. That's what I thought. Okay, let me explain a little bit about myself and how I started in this journey of soil health. Folks, I grew up in the northern part of New Mexico. Our family's been there about 500 years. Old Archuleta is a Basque name. We've been there when the original Spaniards came. In fact, we have a county called Archuleta County. And my dad said, "Son, I want you to do two things in life." And I said, "What's that, Dad?" He said, "I want you to work hard and don't marry your cousins." And I said, "Okay, sir." I married a girl from Missouri. It was wonderful. We've been there for a long time, and I've been in agriculture for a whole part of my whole life. I knew when I was 15 years old, I was going to be in agriculture. And started my journey, did a couple of years of Peace Corps, went and got my college degree, did a couple of tours, and I did a tour in Guatemala. But then I've also lived in 4 states. Started off my career in New Mexico, so I know real dry. Grew up in the Rockies. And then from there, I did a lot of design of irrigation systems. Then my wife and I went to the Boot Heel, Missouri. Now think about this. Grew up in a dry area, and they put me where there's 60 inches of precip, and they grow rice. So I have experience with rice, cotton, you name it. Lasted about 5 years. I said I got to go back west. Became a district conservationist. My county, ladies and gentlemen, in Oregon, 6 million acres. Range, 300,000 irrigated acres. Stayed there for 5 years. But here's where my journey started for me, folks, where I started questioning things about the way we were doing agriculture. Because I think when I walked out of college, I must have eaten the books and missed the point. But I'm beginning to find out as I go all over the country, many people have missed the point. And I don't care what university you landed up, I did not know what the goal was. I felt I was taught out of context. And I'll explain that in a little while. But here's how my journey started. And I'm going to share this because I think it's very critical to understand where this soil health movement, it started with the fact that my farmer, my personal friend, went broke. The cost of inputs actually caused him to lose part of the farm. And I took that personally. And that's considering Idaho has phenomenal soils, we have cheap water, and he is incredibly frugal and a hard-working individual. He could not bring his son into the operation. That bothered me. And the worst thing about it, ladies and gentlemen, we were both standing on the solution. The problem was he was destroying his soils, and he didn't know it. And I went to graduate school for soils, and I didn't even know it. So I'm going to start on this journey on how we can bring healing to the land. My job as a soil health specialist, I go all over the country teaching about soil health. Last year, I taught over 5,400 people, 30 states, and did 60 trainings. Folks, I'm so excited about this because this is where agriculture is going to go in the future. And we're going to start with this journey. Gentlemen, you ready? Come up here. When I go across the country and I am invited to go speak at a grazing or no-till, I don't talk about no-till, don't talk about cover crops. I do not talk about grazing until we do these demonstrations, because I realize a lot of our landowners and our agency people are disconnected from the land. What I mean by disconnectedness is if you don't know how your soil functions, basically, you're disconnected. And I'll tell you about that in a little more. I chose these two gentlemen, and what they're going to do is we're going to go up here and we're going to project. I'm going to stand right here in the front. You gentlemen get ready, and I'm going to show you these clods. Aggregates, pads, call them whatever you want. let's zoom in here, and I brought 2 North Carolina soils, and I always bring my soil. I try to collect soils from every state I go to, and I do this demonstration all over the country. Okay, this soil, can we bring down the lights just a little bit on the front? Is it possible? So we can see the, okay. This North Carolina, I want you to see the color distinctions. Go ahead and bring the lights just a little more down. Okay, though, on the left soil, right here, the clod right there, that is conventional sea soil sandy clay loam, vegetable garden, not a vegetable farm, not a garden. I want you to notice that, and then, oh, that's too many lights. Oh, no. Okay, now. Okay, now let's go to the next soil. Now zoom back out. That is the same. I want you to show both soils. Look at the color difference. That soil on the right is 3%, 2.75% organic matter. The soil, that red lookish color, is 0.5%. This soil is no-till. It's been no-tilling for 40 years. The gentleman just turned 80 on Sunday. This gentleman has gone down from 5 herbicides down to 1 herbicide. He has not used chemical nitrogen in 19 years. He has not used phosphorus in 9 years. How does he do it? It's an old dairy, uses some manure, but it's driven by the multi-species cover crops. This man has been doing 8 species cover crops for 30 years. The Germans have been doing it since the 20s. Now, let's zoom to the other one. Now, you're going to hold that, Ronnie, and you're going to get ready to, I'm not going to tell you to drop him yet. Okay? Now, how do you pronounce your name? Dale? Dale? Dale. No, just Dale. Okay, Dale's going to zoom into those other soils. Now, this is our beloved South Dakota. And I'm going to tell you, ladies and gentlemen, I would love to have South Dakota soils comparing to these Piedmont soils. These Piedmont soils are inherently poor. Inherently poor soils. Okay? It's like a Volkswagen. You guys have Cadillacs. I did this in Iowa. You guys have a Cadillac. Okay. We'll see how good your Cadillac is running. Now, these are conventional and a no-till. It's been no-till how long, Jason? Corn, soybean, pretty much. A little bit of wheat, right? Okay. You're going to hold these 2. Okay, now, it's kind of fragile. Now, what we're going to do is we're going to drop these into the cylinders. And here's the thing, and you can do this at your own home. In fact, I suggest do this on your farm. The only thing what happen is that your feelings might get hurt. Mine were hurt, so might as well get over it. Okay, this is called the aggregate stability test. Scientists call it the Slake test. Very sophisticated test, but I use it in a very simple way. Okay, a healthy soil should not fall apart. Healthy soil should not fall apart. As soon as we drop it, each clod is filled with millions of pore spaces. The water's going to rush in to fill the pore spaces. We want to see which one has the integrity and still hold together. That has the biotic glues, the organic mineral complexes to hold the soil as those kinetic energy, the kinetic forces enter to fill those pore spaces. Let's see which one holds up together. Okay, go ahead and drop them in. Now, I want you to notice old Ray Steyer's 40-year no-till. Look at his conventional. These 2 farms are a mile apart, ladies and gentlemen. Same soil type. Look at the conventional here. And look at our no-till. How's it holding up to my old Volkswagen with the V8 engine? Look at my precious no-till Cadillac with 1 cylinder. Ladies and gentlemen, Ray Steyer's grew a crop of silage last year with only 11 inches of rain, while the neighbors got zip. He's been doing that consistently. because the soil is healthy and functioning. These soils are driven by diversity. They are resilient. This is the best crop insurance I can ever imagine. And you know what I love about this crop insurance, guys? You don't have to deal with the government and fill up paperwork. You don't have to. This is what I love about this crop insurance. It'll help you get through the drought. It will give you true freedom. And what do I mean by that? The less you are using petroleum-based products, the more true freedom you got in your operation. Less diesel, less fertilizer, less herbicide. And you know what, folks? You know what the beautiful thing? I said, Ray, you could be organic. He goes, Ray, I'm 80 years old. I don't even buy green bananas. I might not enjoy them. See, to him, it's not about being organic. It's about, it will go to organic if you farm in nature's image. Now, notice this system. Can you see? Can you go to the bottom right here? I want to see how much collected. Look how much collected. Look at Ray's soil on the bottom. How is this thing? These biotic glues. Now, what happened to the conventional? Why did it fall apart, ladies and gentlemen? Here's how it works. The moment you till, and I can't get my dad to stop using that rototiller. I'm telling you, the moment you till, what you do, you run that disc, you run that vertical till machine. What you do is you open the soil, you push oxygen into the system, and then you wake up these bacteria. Soil ecologists call them our strategists. Some call it copotrophic bacteria, from the word copious. These bacteria start multiplying real quick, and they start to eat the organic matter and the biotic glues you work so hard to build up. Where do these R strategists come from? They're in all our soils. We need them because these R strategists, these copotrophic bacteria, is what helps break down the residue and the manure. They multiply very quickly and they die off. The problem when you till is not only do you open up the soil, you expose them, and then you just fed them the house. You just fed them the house. Oh, and guess what else we do? We bring weed seeds to the top of the surface. And the weeds tell you, thank you very much. All in one event. I know. I used to do it in my place all the time. I'd run the disc. And I did not know I was destroying the integrity of my soil. And there goes the organic matter. Now let's go to the next one. Ready? We're going to see how important, because I don't know about you guys, we've been having drought 5 out of 7 years in North Carolina. And we have 45-inch precept. See, a drought is when you don't get rain. Period. If it goes by you, you're in a drought. From your perspective, right, Dale? Okay, now Dale is going to hold this. Ron. Okay, now they're going to pour. Ron is the conventional. Dale's the no-till. The same two soils, ladies and gentlemen. Let's see which one filtrates. We're going to create a little miniature water cycle. We're going to see, because I don't know about you guys, I want the water in my soil. If I get 1 inch, I want that whole inch. I don't want it to run off. Let's see what happens when we pour this water. And oh, by the way, it's only food coloring. It's not magic dust. Okay, ready, pour. Conventional and no-till. Yeah. Just giving a lot of feedback. Okay. Oh my gosh, the no-till. The no-till. See, I grew up thinking if I fluff that soil up, I'm going to allow more air in. How many people thought that way? Everybody should raise their hand. That's what I thought. When I designed my irrigation pivots, farmer calls, hey, don't you guys know what the heck you're doing? I didn't know he had disked the snot out of that soil and destroyed the aggregate stability and sealed the soil surface. Folks, we can put all the drain pipe we want. If you're still disking, destroying the upper part of the 2 inches, your drain pipes are worthless. You've got to have contiguous pores from the top all the way to the bottom. And how do we heal it? We'll show you in a little while. Okay, guys. Give these guys a big hand, would you? Now we're ready to learn, because I had to go through these paradigm shift about the soil. I had to realize, ready? Yeah. I had to realize that I did not know, and by the way, graduate school in soils, this was not taught in my soils class. And I'm beginning to find out, as I talk all over, I don't care where you graduated, this was not taught either. And how important it is to understand soil function. Now, let's go down this journey, because I have a bad habit of putting too much, not for urban areas, bad slide, but I wanted you to see how beautiful that slide is. Now, folks, here's the 3 basic principles I want you to focus on. If you're going to build soil health, number 1, understand your context. Oh my goodness, context. Context number 1. Your farm is still part of the ecosystem. It never stopped. It still wants to be treated like that prairie and that forest. It still wants to be treated that way. It demands diversity. If we're going to wean ourselves from some of these inputs, you have to understand the ecological context, that your farm is ecologically driven. Other context, ladies and gentlemen, it is no longer about our country. It's about the world. And China and India are putting huge demands on all the globe's resources. So when I walk out on a farm, I look at it from a global, from a national, from an ecological context. If I'm invited to your farm, I'm going to assume that your farm is degraded until I am proven otherwise, because I know there's going to be hundreds of years of tillage that has happened on that operation, that has degraded our soil systems. The other, protect the soil habitat. I have farmers in Indiana that I work with, heavy clay gumbo soils, growing 200 bushel corn. They treat that soil like a habitat. They won't even let their workers with a lunchbox get on the tractor. Too much compaction. You're saying, wow, that's crazy. Oh no, he understands it's a habitat. Folks, and that being a habitat, it doesn't want disturbance. And we got to cover it as much as possible. The other, food. It's all about food. How many deer hunters do we have in here? Pheasant hunters. Folks, cover food. It's simple. Those micro herd on the bottom, the wildlife on the bottom want the same thing. Food and cover. Is that one messing up too? I can actually hold it if I have to. Okay. Hello? Can you guys hear me? Okay. Now, and it's got to be diverse food, diversity. It can't be the same food year after year. Okay, now, but what is the biggest problem? Gay Brown, one of my friends, he said it's the human mind. That is our biggest reason we have the problems that we have today in our resources. It's the way we think. It's the way we look at the system. Now, here's what I want us to start thinking about. The interconnectedness of everything. That's what I love about ecology and biology. It tells me everything is connected. See, you see this thing circling right here? I never knew that the microbes, the cow, the human, they're all connected. In fact, every one of us have 6 pounds of microbes in our bodies. We're like 10 billion cells walking. 6 billion of those are the microbes. Folks, I never knew also. Now, what do I mean? Because I'm going to go around asking. That's why you have name tag. You thought because that I couldn't call on you. Wrong. When I say our soils are subaquatic systems, what does that mean? Russell? What does that mean? Our soils are subaquatic, ladies and gentlemen. Come on, Chris, help Russell. What does it mean? Good, water. They're water dependent, guys. Protozoa are aquatic. Nematodes are aquatic. Bacteria are aquatic. If we cannot get the water in the soil, they are not going to cycle nutrients. I'm sorry. It's aquatic. It's an aquatic. Even the desert soils, if they would shrink us, it would be 95 to 98% humidity in the soils. So how critical it is to get water is very critical. Look at that soil, has not even filtrated yet. Folks, I was taught out of college the Green Revolution. We're going to feed the world. To me, that's a crock. I serve in the Peace Corps. I understand people are starving because they cannot compete with our agriculture, ladies and gentlemen. They harvest corn on mountains like this, and we harvest it by throwing it down. We're going to need every farmer producing in the next 20 or 30 years for the 9 billion that are going to come. And we're pushing the genetics. We're pushing other things. That's not what's going to deliver us. It's biomimicry and mimicking nature. Instead of beating her and fighting against her, I say, let's go to the brown revolution so we feed everybody and let them feed themselves. That's where I think. And how? It's because we have farmers like this, and I don't call him no-till farmer because I hate the word no-till, because it doesn't communicate to anything to anybody, especially outside agriculture. I call these guys regenerative farmers, ecological farmers, but not no-till farmers. It just happens they all do zero-till. Ray Steyer's 80 years old. He's the gentleman that's telling you his soils are phenomenal. None of the soils all over the country can stand up in the slake test like his. Dave Brand, Ohio, Carroll, Ohio, 230 bushel corn average, less than 60 units of N. He's now convinced he can go a lot lower. Steve Groff, same thing. Gabe Brown, a good friend of mine, 6,000 acres, North Dakota, 2,000 cropping. He has completely eliminated phosphorus and nitrogen in his operation. He's completely gone down from a bunch of herbicides down to one herbicide every 3 years. Now, please don't misunderstand me. What I'm trying to say to you is the biology is providing the phosphorus and the nitrogen, making it available. It's not a license to deplete. It's that they know who's driving what. How did he do it? Zero-till, multi-species grazing. He's doing, yes, multi-species grazing. He's doing mob grazing, and he's doing multi-species cover crops. Ray McCormick, he's the one that went up to Chief NRCS and said, Chief, we want soil health. Don't tell us about anything else. Teach us soil health. President of the Indiana Conservation Districts. Folks, why? Why is this more critical now than ever? This is what I see when I drive the country. The soil is naked, hungry, thirsty, and running a fever. It's naked because it doesn't have its covering. Folks, I grew up in New Mexico. I thought that was normal. It's not normal. It's hungry because it's covering, it's not capturing solar energy and feeding the microbes. Thirsty because the water's running off and running a fever. Those temperatures get up to 150 degrees. At 140, you're killing microbes. At 113, you are denaturing enzymes in the soil. And it's the enzymes that run the nutrient cycling. This is what I see when I go across the country, ladies and gentlemen. I told the EPA, this is my pictures taken off an iPhone. I sit in the window seat, Tom. I said, look, the soil's bare. I said, EPA, we don't have a runoff problem. We have an infiltration problem. Runoff, when you say runoff, it's reactive. It's too late. We have an infiltration problem. It's a symptom. Our lakes and rivers are filled with conservation plans and nutrient management plans, but are not crystal clear with understanding, ladies and gentlemen. Look at here, my beautiful lake right next to my house. Look at the color. Look at the buffer around it. This happened in Lubbock this year, folks. Oh, this is wrong. This is Australia, and this is Lubbock. I drive all over. Texas is bare, and it's going to blow. Western Kansas, it's going to blow. So, this is what I tell when we sit in a class. This is the first thing I ask in a class. Okay? What is the problem with that picture right there, resource-wise? This is Indiana. This is Michigan. Your name is? Darren. What's the thing you noticed right away? I would have got this wrong, by the way. I want to make everybody feel comfortable. I would have gotten wrong. What's the resource problem right off the top of the bat? What? Lack of residue. What else, guys? What do you think? The buffer's not big enough. The diaper's not big enough. And I like diapers. Folks, it's right here. That's 15% slope after it's been tilled. The battle is right there. If you do not address it right there, you've lost. We have an infiltration problem. Folks, I want you to look at an electron microscope. I want you to look at the image right here. This comes from Ray Weil's book. This is conventional, no-till. Look at the pores. Which one do you think the tile drain would work better with? The one with lots of pores on the top surface, 9 millimeters? Or this one? Why is this being a bigger issue now than ever? Folks, I got this from Brian Lindley. He's sending it around. Very interesting, no-till in the plains. The Institute of Global Environment and Society just came up with their new models. It's about 2 months old. They're saying, I want you to look at the picture of the Midwest. We used to have drought 5 out of 50. They're saying we're going to get drought 20 out of 50 years. That wasn't very encouraging. We got the solution, soil health. Show you. Where's the rain going? Now, this is my own personal opinion. I cannot prove this. I think because our soils are not functioning, our land is bare, I think that we're pushing the rain away and creating our own droughts. Let me show you. You see this right here? This is the picture of the United States. Look where the rain is falling. It's being pushed out because the temperatures become so hot. It is vegetation that brings in the rain. Now, folks, this is a satellite imagery showing 66 degrees Celsius is 150 degrees. I want you to notice the soil temperatures all over the globe. Do you see this whole part? Look at the size of the United States, the Sahara. The Sahara Desert, ladies and gentlemen, used to be vegetated. It used to be a grassland. Hannibal crossed it with elephants. You don't cross the Sahara with an elephant. It's like going from South Dakota to Iowa on an Abram tank. It's going to need a lot of fuel. Look at the soil temperatures. Folks, and we need to understand that we're all connected together. The weather here, these hot soils impact the climate all over. It impacts all of our climate. So I'm saying, when I first came out about global warming, I wasn't a big advocate, I'm going to confess. But the more I started studying about our soils and how the water's running off and it's not cooling, could it be that our soils are dysfunctional? And the way we can heal this land is through vegetation. Can you imagine if all the Midwest was covered with covers at the end of the year? This is a satellite imagery showing, pushing, that this huge storm is being pushed off the Horn of Africa. It's just being pushed off because of the hot climate. Okay? Now, here we go. There's Dr. Rakowski's work. It's showing this is really cool little imagery here where he's done some research on tillage. And then he measures, got a laptop in there and measures the CO2. The reason I bring this up, folks, is why we're still having this discussion about tillage. We thought we would have learned in the 20s and 30s. Forest, 17-year monoculture soybean, same soils. Now look at this. Now this is very interesting. They did some studies, Dr. Kathy Siebold, they took the measurements of the forest and they did the Capic loam, same soils. Infiltration rate in the forest was 50 inches per hour. The corn soybean conventional till was half an inch per hour. Half an inch per hour. Now, here's interesting. Now, if we're going to do nutrient management, we got to get this one right. The forest only had 1.8 pounds of nitrogen in the soil system. The conventional had 15 pounds of N per acre. Why do you think that is? Okay, tillage, that's good. What else? What do we do? We add a lot of fertilizer. What else? I'm going to give you a hint. It's green and it's on top of the surface. Organic matter? Well, we got more organic matter. But what else does the forest do? Doesn't that covered all the time and having living covers? I want my nitrogen immobilized in the microbe, in the cytoplasm of the microbe and in the root. I don't want it leaky. So how do I fix that? Covers. Nature's covered all the way, 24/7. This is my beloved New Mexico in Albuquerque. This is Albuquerque, ladies and gentlemen. I want you to notice that. Irrigated alfalfa, 10-inch precept, same soil, 2 diskings. Richard, where did the earthworm come from in the desert? He lives on organic matter, huh? Did it cross the border at night? No. It didn't cross the border. If you provide the right biology, they will come. They will build it. This is irrigated alfalfa, 3% organic matter. You shouldn't be able to build organic matter of 3% in a desert soil. But he does with very little disturbance. Look what 2 diskings did. Life, the moon. Life, the moon. Folks, this is where I get so passionate about. These are our 2 challenges for the future. It's fuel and water. Fuel and water. Solution for agriculture, mimic nature. So we use less water, less fuel. Doesn't that sound cool? And you got control. That's the cool thing about it. So, here's your first homework assignment. Oh yeah, you thought you weren't going to get homework, right, Dwayne? There's going to be homework. I want you to Google, anybody that's likes the computers, and type the word TED. You're going to get into this search engine, and you're going to type the word biomimicry. Oh my goodness, that woman is inspiring. It's talking about how mimicking the biology, we can solve a lot of our resource issues. She says, nature's got 3.8 billion years of research and development. She's got 10 to 30 million species with the answers. All we have to do is watch and observe. She's got the big ideas, and her name is Janine Banyas. Just type Janine Banyas or biomimicry. You want to be inspired? She's phenomenal. This is what gives me hope, mimicking the biology. What has Dwayne been telling us for years? Here's some example. They're using the shape of the fish to make cars now give it 20% lower fuel by mimicking the shape of the fish. Very cool. How about these two bugs? They never drink water. It's their exoskeleton and the way they'll be able to attract the water, sucks the water from the humidity. Scientists and archaeologists, engineers and architects are now using that kind of design and building on buildings outside so it can suck the humidity and pipe it right into the building. Very cool. Oh, by the way, how did the Wright brothers learn how to fly? The birds. Or were they smoking a lot of cover crops? And said, hey, I got an idea. No, they watch nature. Look at the book of Job. But ask the beasts, and they will teach you, the birds of heaven, and they will tell you, or the bushes of the earth, and they will teach you, and the fish of the sea will declare to you. Now, I don't want you going back there and go speaking to your earthworms. That'll be disturbing. But Ray told me. But folks, the answers have been there. It's the prairie. It's biomimicry. It's mimicking the biology. Folks, this is my context now. When I walked out of college, if my professors would have told me, Ray, this is your goal, mimic nature, then I can discern all the science, if it's right or not. There's a lot of science out there. If it doesn't teach me to emulate nature, I don't have time. I want my soil to function. Land then is merely soil. It is a fountain of energy flowing through a circuit of soils, plants, and animals. Once you understand everything's connected, guys, quantum physics, all is one. Ecologists, all is one. Theologians, all is one. Connectness. Everything you do out there impacts something. Now, this is where I started questioning a lot of my nutrient management. Folks, I walked away from college thinking soil is just a big chemistry set. I throw all my chemicals in there, and presto, the black box. There's cations flowing around. I got mass flow, interception, diffusion. I got that drained in my head, drilled in my head many times. And this does happen, ladies and gentlemen. But it's the wrong paradigm. This paradigm is causing, look at the research, 40 to 60% of our N and P is lost because I think of the soil like this chemistry set. There are researchers all over the country, Dr. Drinkwater from Cornell, questioning this paradigm. Dr. Michael Swift, another brilliant scientist, questioning. I'm questioning. I'm beginning to question the way we looked at it. Bare fallow 4 to 8 months. We have decoupled the carbon and nitrogen and phosphorus cycle. This is the paradigm I want to convey. Ladies and gentlemen, they drive that. It is an ecological system. It is a complex, beautiful system. It's based on the plant and the microbe. They drive it. By the way, page 725 of Brady's book, I think it's 725, pretty close to it. What did it say? How much percent of our fertilizer, when we throw it in there on the soil, actually goes into the soil? To the plant. What do you think, Russ? What percentage? That chemical fertilizer you throw, they did a radioisotope and tracer N15, and they followed it up. How much actually went to the plant? 17%? What do you think? Not far. Hey, might as well guess, right? I was guessing too for many years. Folks, 60% of this, only 40% actually goes into the plant. What happened to the other 60%? Now, you paid $1,000 a ton for. They went into these complex organic mineral pools, folks. The mafia. they deal with a lot of this. Now, here's your most powerful tool. Here's your first question. Okay, now I want you guys to be honest because I know you will be. How many of you use that powerful tool to determine if your soil is functioning or not? Raise your hand. That's what I expected. Folks, if you go to Gabe's, if you go to Dwayne's, they have a shovel with them. Ray Ward have a shovel with them all the time. I carry a shovel every time I get a chance. Folks, this is what I want you to think about. Now, you're going to look at these big words and you go, what the heck? Folks, the reason I keep those big words is because I want to show you that this great scientist, soil ecologist, said, look, we need to have a drillosphere. That means worm sphere, drillosphere, sphere, area of influence. Think of it. I'll put it in these terms. Think of it as a 5-cylinder tractor. I got to have all cylinders running if I'm going to get biogeochemical nutrient cycle, biological geochemical cycling. The agronosphere is the crumbs, the cottage cheese. The detritosphere is the residue sphere. The rhizosphere, the most powerful, all of them together. This is what causes my nitrogen to be available to my plant and my nutrient. All cylinders working. So when I pick that shovel, I want to see crumbs. I want to see crumb structures, cottage cheese, and I want to see 5 to 10 earthworms per square foot, or 5 earthworms per shovelful, at least at the minimum. Then I smell that earthy smell. I want to smell that actinobacteria present. If there's no smell, there's something wrong. Basic shovel, very powerful tool to tell you if your soil is functioning. Okay. Now, you don't have to remember all these cool spheres. Just know that you got to have that residue. I want to see earthworm holes. Now, this is my favorite little slide here. Now, this gives me goosebumps. Folks, I want you to see, this was taken by Odette Menard from Quebec. Folks, look at my factory workers. I don't have to pay them overtime. I don't have to put diesel in them. Look at those earthworms. You have a residue problem. You have a soil biology problem. You need 4 times the biology to feed those babies. Look at that. Isn't that exciting? What is your name? Jason. Now, does that give you goosebumps? No. It gives me goosebumps. Can you imagine Jason out there? Jason, go check the corn. Jason trips. He's gone. All you can do is find a shoe. Earthworms took him. Where's Jason? I don't know. The earthworms must have taken him. That's what I want to see. Folks, I was shocked they can do that. Now, Jason, what if I tell you to go check the corn? Oops, missed the one. Look at the infiltration on that. Folks, when you got all that infiltration, that means you're going to capture every bit of water. And guess what's in those wormholes? Bacteria laden with, and there's also phosphorus and nitrogen, and the roots follow them down. See how that's all tied together? 11% more humus, 7 times more nitrogen, 11 times more phosphorus, 9 times more potash. Folks, these earthworms are helping the whole situation. There's my cottage cheese. That is Gay Brown soil in North Dakota, 16-inch precip. They got a 12-inch rain in 13 hours. It should be mush. It's not. Those glues are hydrophobic. They shed water. Those glues that are present, there they are. The coatings, mycorrhizal. I love those mycorrhizae. This is what helps you get the zinc, the phosphorus, make it available, help you get through the drought. Guess what they hate? Fungicides. They hate tillage. They hate overgrazing. Too much phosphorus, over 200 pounds of P, shut this association down. People say, well, I want to manage how much phosphorus in my soil. I look at 200 pounds of P. I talk to my dairy guys. You putting too much phosphorus, you're going to shut down this association. Research from Colorado State. There it is. So if I have somebody that's putting too much P, I'm going to shut my babies down. I don't want them. They're the ones that help me get through the drought. They're the ones that make zinc available. They are the ones that help me get through the drought and capture water. I need these mycorrhizae. They give me a huge influence. 100 parts per million, 200 pounds of P. Why do I care? Look at those aggregates, those cottage cheese. They do everything, folks. They influence the community of the microbes. They limit oxygen diffusion. They regulate water flow, absorption, deabsorption, all this. Look at the research. It's been there for a long time. Now, corn and soybean. Corn and soybean, just don't cut it. If you ever want to be sustainable, if you want to be free, truly free, look at the aggregate stabilities. I want to build lots in aggregates. Aggregates will only last, on the average, 27 days in the natural soil system. That means you've got to be replenishing it all the time with living carbon. Cover crop, corn and soybean. For corn, and then alfalfa. Look at that. And look at the rotation. Corn, oats, wheat. Look at the aggregates you're building through diversity. Look at the calcium that's being held by the fungus. I never knew. Those are calcium crystals. That's an electron image. How can calcium be held by fungus? Dr. Elaine Engham's been talking about that for a long time. Soil microbiologist. Now, here's the most powerful thing you can do to reduce weeds. The living seed. You will never till them. You will never disc them. Fill the niche with a living plant. Look at the moment you put the seed out there, that cover crop, that living cover, they start sending chemical messengers to each other. Each plant has its own chemical signature. Look at that film of sugar coming down. Folks, that root is coming down at 1,400 psi. It is leaking. I want that stuff to leak into my soil. I want my little microbes. Those are cells. And then in there are the microbes. This is the most powerful thing that happens right here. Here's where nutrient cycling, here's where vitamins and all this, where the microbes and the roots interface. That's how the plants are able to get all these cool vitamins. Healthy soil, healthy plant, healthy animal. It's all connected. Look at the protozoa feeding. The protozoa, according to Dr. Lavelle, guess what? These bacteria multiplying and this nematodes grazing, really cool, they're grazing on these bacteria. You can get anywhere from 16 to 117 pounds of N. What are those bacteria full of? Protein. Protein becomes nitrogen. Okay, we're running late, huh? Okay, amino acids, organic acids, sugars, vitamins, all these things. This is what I want to leak. Amino acids is another code word for N. I want all these things to leak into my soil. Robert Pinto, fantastic book, Dr. Ward. I recommend that book. It's about 500 pages of coolness on just the root and what leaks. We are taking covers to a different level, guys. We're going to do rhizoengineering, where we can manipulate the biology by the living covers we put. Because I want diffusiates, sugars, organic acids, excretions, secretions. I want all that to leak. And you can only do that by putting a cover. Now you got negative communication and positive communication. I don't have time to go over that. Oops. Oh, by the way, this slide's out of place. But since you guys want to know how Ray Steyer does it, that's his 8-way mix. I'm rolling it down. He does that every year. Look at the biomass. Wade, if you saw that, did you freak out? All that residue? How about you, Ron? You go, what the heck am I going to do with all that cover? That's food. That's carbon. That's his fertility. Oops, another slide out of place. I just wanted to show you the far where I took when I fly when I go all over the country. Now, scum test. How much time before the break? It's already 5 more minutes. Okay, now look here. Look at alfalfa. Look at all those things that leak. Dr. Chris Nichols' slide. Look at alfalfa. Look at all these compounds that I want leaking. Big stems, switchgrass. Look at alfalfa. That's why I love alfalfa, and you no-till corn into it. Oh my goodness. Nice. Now, look what happens when we use the right covers. No cover crop. North Dakota, cover crop. Look at the allelopathic effect. Nice thing I like about that, I didn't have to put diesel in the tractor. I didn't have to put a herbicide application because I put the right cover. I got weed suppression. Cereal rye, folks. Pigweed hates cereal rye. Hates it. Cereal rye is phenomenal for weed suppression. Russian thistle hates cereal rye. That allelopath, that leakage, I'm getting herbicide control. Now, this is what I love. This is Dave Brand soil. I want you to look at those nodules. You can't spread urea that good. That is phenomenal. So what is it? Diversity. Diversity is the conduit of where nutrients and energy. The more diverse my system, the more I'm going to get energy and nutrient cycling. How much time? Am I still okay? Oh, good. Now, where did I start learning my paradigm shift? As soon as I got hired, I went to North Dakota and said, Ray, you're going to teach soil quality. I am? I said, yep. You're going to teach it because you're perfect, because you don't know very much. You know nothing. It's perfect slate. I didn't even know what no-till was 8 years ago. Nope. Did not know about no-till. Folks, I'm from the West. We make talcum powder over there. It's a growing medium. We beat it until it's talcum powder. And I said, now I'm going to think like an agroecologist. I found out that nature is more collaborative than she's competitive. I walked away thinking nature is more competitive than collaborative. This is how it worked. They did a test plot. We had 1.8 inches in 2006 in Burleigh County. What these guys did, lupin, they put it monoculture lupin, oilseed, pascha, purple top, and cowpea. Threw it all in one plot. And in the last plot, they threw all this together. Remember, 1.8 inches. Now, let's look at it from a visual perspective. Monoculture, 1.8 inches. That's what we should expect with 1.8 inches, right, John? Yep. Looks pretty bad, right? How about oilseed? Terry, we should expect that, right? Now, look what happens when we throw all the seed together. 1.8 inches. Here was the plot right next door. See, I was told that you will still, if you grow crowded together, you will steal nutrients, water, space, sunlight. That's what I was taught. I don't look at it that way. In fact, I don't even look at weeds like most people look at weeds. Weeds are nature's scabs, and they're plants I do not understand. Folks, because of understanding the collaboration, we are changing the landscape. And we're going to take a break, and we're going to finish up right afterwards. Okay? There's a sheet of, there's a paper called The Ecological Role of Biodiversity in Agroecosystems. If you do not have one, there's a link to this. It's 11 pages of steak, ladies and gentlemen. Read that. I read that 4 or 5 times. It ties the biology, the biodiversity to the top, to the bottom. It's by Dr. Miguel Aguirre. Dr. Aguirre is in Berkeley. Awesome entomologist, excellent paper. Please read that. And you might say, oh my gosh, may look a little difficult, but it's really not. Read it 4 or 5 times. It is worth it. It is worth it. Great paper. And cutting out? Okay. Okay. It's that white paper. It's called The Ecological Role of Biodiversity in Agroecosystems. 11 pages of wonderfulness. I mean, it is worth reading. I don't give you stuff that's not going to be worth reading. It is excellent. Now, remember, we were in the moment talking about, oh my gosh, the power of diversity. They said this won't work. Well, this is eastern Montana, ladies and gentlemen. You know what that is? A multi-species cover crop growing with less than 10-inch precip, wheat fallow area. It's not supposed to be growing in that area. But it's amazing what happens when nature is adaptive and you put the right thing and what happens to it. Look at that cover. Eastern Montana. If any of you have been to Eastern Montana, it doesn't rain very much over there, folks, and it's cold. And these mixes, we're doing those mixes over there. Again, where I've learned a lot of stuff is advancing the soil health is right here in Burleigh County. It is worth going. It's like going, there's 3 places that I'm going to take the chief to Dwayne's place, to North Dakota, and to Dave Brandt's place. And that's where we're going to learn about the biology and the ecosystem. But I love what they talked about. It doesn't say advancing no-till. It's not about no-till. It never was about no-till. It's about making that soil and emulating nature to make it healthy and functioning. You know what the Minokan farm people did, the district did? They bought their own farm, 150 acres. Said, we're going to do our own demonstrations. We need it now. We need it now. We need the information now. You guys are fortunate you guys have one in South Dakota, where Dwayne's at. And guess what? Missouri now is getting one. They went to one of our workshops, and the utility department said, hey, district, we'll give you rent-free 160 acres. So the district's going to run one there too. This is spreading. Dave Brandt, his farm is a soil health farm where we're learning all over and we're taking soil health to where it needs to be. Here's where, and I remember that year, when we went over there, the guys rolled a cover crop. This was a 14 to 16-inch precip, 16-inch precip area. Those crimper rollers are fantastic. They rolled the cover crops. This is what the district did. Now keep in mind, this farm was 2.75% organic matter. Should be 5, 6, 7, 8, that part. Very degraded wheat fallow farm. They planted an 8-way mix after they rolled it. Then, here's the mix. No commercial fertilizer. They let it winter kill. They no-tilled right into it. And this was the result. No commercial fertilizer, no compost tea, 122 bushel per acre. The county average for that area is 100 bushel. No commercial fertilizer on this one is 2 tons of compost, 2 compost tea applications, 128 bushel. And I said to myself, conventional agronomist, where did the nitrogen come from? This is a degraded system. This is first year no-till. It's like Jay would say, we increased the biological time. What this taught me is how powerful the metabolites that leak in those roots that stimulate the biology. It's the biology that drives this system. That's what it taught me.
What is that tea?
Oh, compost tea. How many know what compost teas are? Compost teas is where you get the compost and you get the bugs out of it. You want the organisms and you spray it on the surface of the leaf. Rodale Institute has been doing some research on that for disease suppression, but we've seen better response through reducing the nutrient inputs. So I said to myself, well, why would I want to do compost teas and put them on the surface of the soil? Well, then I started doing some research and I found out there is a phylosphere. Now I'm using those spheres again. Philo means the surface of the leaf. There are millions and billions of organisms that live on the surface of the leaves. Folks, why would these guys, you guys heard about the story about the guy that put raw milk on wheat and got a 10 bushel increase. Well, the Minokan guys, the North Dakota guys, did the same thing. Got a yield increase in their canola. I said, okay, now hold on a second. This is messing up my mind. But then when you start noticing that you have the phylosphere, you have the drillosphere, you have all the biology and the ecology, you start connecting, it starts making more sense. Because I want the most explanatory power. It's about ecology and biology and putting it in the right context. So what we're teaching our farmers all over the country, and I've told the guys here, this is a 2-day course where we teach people how to design their own mixes, how to do better rotations. Because what we're telling people is, look, we want to put covers, look at our leeks, the spring and the winter. I want living covers as soon as possible. We have farmers that will hire people in Pennsylvania. They will hire workers because they got the no-till drill going right after. They have reduced their variety days. They've gone from 110 to 90-day corn because they want those living covers. Because we don't want any nutrients leaking. We want to stimulate biology. We want to stop the leaks. Because it's about having these living covers at the end of the year. We want to have those living covers, and we're willing to reduce our variety. And then we have variety corn, Gay Brown, 78-day corn, 159 bushels with no N and no P. The covers, the diversity, the mob grazing, putting it all together. Okay, wheat fallow. Probably one of the most destructive things that ever happened to our country is wheat fallow. Tom, what's wrong with this picture? Why is wheat fallow such a bad thing? My gosh, 6 months of cover, 6 months of starvation. We went to the University of Oregon, and they had that whole area, the Palouse, and the professor said, we can't build organic matter on that kind of system. Yeah, of course not. You're not feeding biology. How about this system? What's wrong with this system, guys? Is that going to work? We're talking about not sustainable. I want regenerative farming. We want to go beyond sustainable. Is that going to work, guys? Why not? Monoculture is going to require heavy inputs, disease, pests are going to eat your lunch. It's not going to be sustainable. How about that one? Is that looking better? It's looking better, right? Not good enough. Now that's looking better. Here's what they did, an interesting study. On page 144 of the Land Institute. It was phenomenal. Scientists went down to the tropics. And what they did is they cleared this tropical forest and they planted corn and soybean. Guess what, after a couple of years? What happened to the organic matter and the nutrients, Ray? It tanked. Completely gone. And then guess what they did? Hey, what if we do this tapestry of diversity and this mimic nature's architecture? What if we start putting maybe not tobacco, but they put cocoa, they put a banana, and they put all these, they mimic the architecture of the plants and they make diversity. Guess what happened to the organic matter? It went back up. The organic matter went up, the nutrients were sequestered by mimicking the architecture of the forest, the tropical forest, and the prairie. The prairie's got legumes. It's got different depths. The only thing lacking here is my 2 cows. There's the prairie. Prairie. Look at the picture of the prairie. Look. This is what we are accomplishing with our cover crop mixes. I'm going to tell you a quick story. I went to Dave Brandt's. I drove 7 hours. Dave was in a little piffy mood. I said, Dave, what's going on? He goes, come here. I want you to look at my Austin winter pea and my radish. They're dead. First year no-till, very, very heavy clay soils. Wet. Comes over here and says, why? I said, what do I do? I looked at Dave. I said, Dave, why did you plant 2 species? You could see that blank stare in his face. He knew where I was heading. Why didn't you put 7, 8, 9? You didn't build resilience into the system. Why does nature have thousands of species? Resilience. It can tolerate the wet. It can tolerate the drought. Something will survive. Redundancy builds resilience. You put 2 species. Austrian winter pea don't like saturated conditions. The radish, they both died. You didn't build resilience. And you wanted it to survive under those conditions. Look at that. Now, the moment you start bringing those plants, we have this. Look at that. Look at my babies. My bacteria right at the bubble, the protozoa are gathering. The moment you put a living plant, that's what happens. Here comes the herd. Here come the grazers. And then here come the protozoa and the nematodes like hyena and cheetah to eat them. Something has to die for us to get our nutrients and our vitamins and all the cool stuff that we need. It's right there. Look at this. That's why we're getting from these diverse covers. They're leaking food and energy. Now let's go to Dave Brent. Now Dave, when I said, Dave, let's try these multi-species cover crops. Ray, it won't work here. This is Ohio. North Dakota special. That's God's country. Nothing works. And I'm being facetious, ladies and gentlemen, because I have had that. That diversity will not work here. I said, really? Okay. I said, Dave, let's try these multi-species. Let's do our test plots. He said, okay. He's open. That is one of the mixes, 10-way mix. 16,500 pounds of biomass. It freaked Dave out. He says, Ray, how am I going to plant into that? What am I going to do with that? I said, panic not. Let it winter kill. Sure, that's enough for you to say, right? Now, this were planted in August, right after wheat. There it is. And he put a bar right in front of his no-till drill, knocked the stalks down. Beautiful. Now, I'm going to tell you this. Dave's a 2-species man. This was hard for him to swallow because he didn't want to do more than 2 species. He's been doing 2 species. He's been doing covers for 30 years. He was doing covers when people think that he was an idiot. But he is not. There's the mixes. Now, here's the proof. This is the drought. Dave got 4.1 inches from May to the second week of September. He got 4.1 more inches, a total of 8 inches this summer, last summer. The drought was bad in Ohio. The neighbors with vertical till, 40 to 80 bushel. Dave Brandt averaged 144 bushels with less than 60 units of N. Nice. Living covers, 30 to 40 year no-till. Look at the corn. Same soil types right across the fence. And the neighbor won't even talk to him. He thinks the soil is special on Dave's. It just, no, the rain landed here. It just boggles my mind. What do we do these mixes? We put them in the drill. We mix them up. I even did it in my 10th of an acre of garden. Look at some of the results. First year, this is the first year data. Now, you're not going to be able to see that, but I'll read it to you. Now, I want you to notice the blue bars is 140 units of N. The red bars are 70 units of N. The green bars are 0. Look at the radish and pea. Okay, look at the 8 species. The 8 species mix, 3 high carbon, 3 legume. and 2 low carbon, the one with produced a bunch of biomass. The one with 140 units produced 155 bushels. Now keep in mind, this was 8.8 inches. Context, context, context. The 70 units produced 147. The 0 nitrogen, 5-year no-till, by the way, 3 replicated plots, 174 bushels of corn with 0 fertilizer after the mix. Now remember, these were all no-tilled into the mixes. Okay? Then we did our 9 species. Same thing happened on this 9 species. 70 units was 171 bushel. There's no fertilizer, 174. And you can see what happened. Dave Brandt changed his mind. He started seeing the power of diversity that we're not utilizing and what can be done. Research shows that we can actually degrade PCBs by putting the right plant. It will degrade them because it rings the right microbe. The biology, it's about biology. And it's not just, but Ray, that's Ohio. How about Pennsylvania? 12 species mix. Replicated plots with Steve Groff. Steve did 120 units of N, 196 bushels. This was 15-year no-till. 90 units of N, 198 bushels. 60 units, 205. Notice, as we drop the nitrogen, the yields go up. And then the mix with no fertilizer, 190 bushel. See, a lot of people don't realize chemical fertilizer is a salt. It is a salt. In old biblical times, you want to get rid of your enemies, you salt the fields. And I'm not opposed to fertilizer. I'm not saying not use it. It is a tool. You have to use it very cautiously. Dr. Lane Ingham, soil microbiologist, always said, be careful with your salts. This is my multi-species cover crop. It's called my chaos garden. I rolled my mix, and I learned this from, this is a book you guys want to write down. It's called The One Straw Revolution by Masanobu Fukuoka. I messed that one up bad. It's a simple read, but this guy was a blasted genius. He could grow 130 bushel rice with no inputs. He said, we worked too hard. So I went and in my garden, had my cover crops. My cover crops were this high, and I went to Walmart and bought all kinds. I bought 30 species. I bought my corn, my squash, my watermelon, and I just threw it out there. And the seeds fell down, and I rolled my cover crop right on top of it. And they all came up. You know what I love about this garden? I didn't have to weed. I'm a lazy boy. I don't want to weed. Guess who else did this? Gabe. He did it on 10 or 15 acres. He always has to do it bigger. There's my mix. Not only did I put a 10-way mix, I made my vegetable garden the chaos garden. I threw all my vegetables out there and let them grow. That's what I learned from Masanobu. He said, we work too hard. Now, if you're very German and very linear, it's going to mess you up. Because I got to have my little rolls. I got to have everything just perfect. Nature doesn't do that. Golf courses, ladies and gentlemen, are ecological deserts. It's not the way nature works. Look at the multi-species chaos garden of Gabe Brown's in North Dakota. Did you see it, Ray? Did you get to go out there and see it? Wasn't that cool? I love that. Biology, ecology. Now, that, Ray, won't work here. Now, look at my Kentucky farmers. That's 90 pounds to the acre of cereal rye. He is planting soybean right into it. Look at that cover. Ron, if you got that kind of cover, it'd freak you out, right? It freaked me out. Look at all that residue. You're going to say, oh, I was going to do that. Look at that planter going right into it. Look at the soybean coming right out of it. We get a 10 bushel increase every time we do that on the average we have observed. We grow right into cereal rye. So what have we done? The cover has extracted the nitrogen. It causes my legumes to nodulate even more. I protect my soil. I keep the temperature warm, cooler. And when the raindrop comes down at 20 miles an hour, I capture everything. I don't want my temperatures on my soil to get up to 113. Now, I'm going to be speaking at the National. Good friend of mine. We became very good friends. He's a district director, and you know how I got him convinced to do multi-species cover crops? The demonstrations. He calls me and says, Ray, we want your help. I said, under one condition. You're coming to North Dakota with me, and you're paying your own plane ticket. Okay? 15-year no-till, North Carolina with 45-inch precip. Now, think about this. 45-inch precip. Why am I taking them to North Dakota? Because I wanted them to see the power of diversity. I said, I cannot take you to the next level until you understand the power of diversity. And I'm telling you, when he saw that 7-foot cereal rye, Tom, he was not a happy camper. He had that facial expression. He was scared. It scared the living snot out of him. I said, don't panic, don't panic. Let's pull out the old cultipacker and let's roll that baby. Let's roll it. Here's where it got real ugly, guys. I told them let's do 10 or 20 acres. They did 900 acres. I did not sleep good for 2 weeks. And John Pickler, the other farmer, says, Ray, don't worry. We'll take care of it. I go, yeah, sure. Okay, so here's where it got ugly. The planter into this heavy residue. Guess who I call? Dave Brandt, farmer in Ohio. He has been planting through covers for years. He tells them just this, and that. And I said, thank you, Dave, because guess what happened? It worked. We adjusted the planter right. You do it when it's succulent. So in other words, we're rolling, do a chemical burn down, and we'll roll that, and you no-till right into that. Beautiful. And this is how we did some of our seed, cover crop seed. This is defoliating cotton. Now these guys farm about 1,200 acres. Cotton, corn, soybean, popcorn. You see that? That's a 6 horsepower Honda engine. And it's throwing cover crop seeds 60 feet out. And they're defoliating cotton at the same time. And look at the way the cover came up. Nice. And you're saying, okay. And look at our corn. 180 bushel corn. He is getting 3 bale cotton this year. He's been using covers now for 3 years now on his own. 3 bales, cotton is excellent. Corn yields, excellent. Is there going to be any erosion? Oh, those slopes, guys, are like this. Slopey ground. My microbes are going to feed on that. And when he pulls that detritus sphere, there's bugs everywhere. I said, don't panic. They're there for a purpose. Leave them alone. No-till tomatoes. Steve Groff's. Look at that. You see any weeds? Cereal rye, rolled down. Pumpkins. He gets 10 cents more a pound because his pumpkins don't have discoloration. They grow right on top of the cereal rye. We are having people from Alabama, all over the country going this direction. Farmers are catching on. That's why cover crop cereal rye is almost $21 a bushel. I said, stop growing soybean. Grow some cereal rye. Let the other guys. That's where money's going to be made, is growing covers. Look at the soil temperature here. This was taken from South America. Look at the soil temperature difference here, folks. No crop residue, crop residue. 86-degree difference. It is huge. Look at the roots. where the residue is. Where there's roots, there's biology. You've got to have roots for them to be there. Look at this. Farmers are pretty darn bright. Once you give them the goal, mimic nature, emulate it, that is a cover crop seed planter on standing corn. Now, that one will make you drool. All the testosterone, you can see it just go up all of a sudden. That goes on standing covers on corn. That's how focused they are. Dave Brandt just went to the bank. He's going to buy one, and he wants to put it into his standing corn. We want that ground covered at the end of the year. We cannot afford not to be covered. How about the drought? We still have drought. Look at our beloved Texas. I traveled through all that, and it breaks my heart to see what's going on. I'm going to show you what happens when you manage, the grass right. When you emulate nature, these farmers grazers are emulating the buffalo. They're doing mob grazing. They're bringing those cows together, very aggressive. I want anywhere from 250 to 500,000 pounds to the acre. And they move in mobs. That's why they call them mob. I call it adaptive grazing. Because you adapt to nature. Look what happens when you overgraze. I'm a weed whisperer. Weeds are telling me you're overgrazing. If you're tilling too much, you have weed problems, you're over-tilling. He is now grazing grass that high, ladies and gentlemen. This is Missouri, north of Springfield, 35-inch precept. I want to show you his place. He's grazing grass that high, and he's bringing 200,000 pounds to the acre. He's completely eliminated haying in his operation. He buys the hay. Who taught him? Doug Peterson. Mob grazers. Look what happens from you go to 200,000 pounds. Look at this smooth sumac. It's a weed problem. 200,000 pounds to the acre, weeds be gone. No herbicide application. I want to tell you, these animals become very aggressive grazers. I have a daughter who's going to be a lieutenant, very picky eater. Now that she's in the military and they mob graze her, she eats everything. She eats everything. Love that now she eats everything here. This is his place. I took that picture. Those are warm seasons that came back on their own. He did not plant it. He did not apply lime. He did not apply manure. All he did is manage his cows differently. Warm seasons came back on by themselves. That used to be a fescue infested. That was during the drought. This is the neighbors, 2011 drought, haying and improper grazing. Let's look at Mark's. Same drought. The only thing that separates it is that fence. Ladies and gentlemen, is it possible that we create a lot of our own droughts? Because we don't manage the cows. We're not connected. We don't understand how the ecology. He calls me in the middle of summer and says, Ray, I get it. I said, what did you get, Mark? It's about the soil, isn't it? I said, Mark, they're connected. You can't separate them. Look at that. Folks, I got to have all these ecosystem processes working. I got to have the biocommunity cycle. I got the water cycle. I got to have all these working together. The nutrient cycle. They're connected. And the way you manage that vegetation impacts those ecosystem processes. Folks, I know in my place, my lawn, I mow it 4 times a year. The neighbors mow it 30. Russ, do you think they like me? I'm walking around the neighborhood and says, Ray, why don't you mow your grass? I said, because I'm managing for the rhizosphere. He said, no, you're lazy. I said, get over it. I'm going to put sheep in the front. Luckily, I'm zoned agriculture and goats. Now, look at this. You think I was kidding? Look at my yard. I have vetch, crimson clover, and my wife said, why don't we throw some sunflower? I said, no, not sunflower. That's just a little, that's too much. I don't know. I'm thinking about it, but I love that. But you know what they did to my new house? They came in there and they moved all the soil, compacted the living snot out of it, killed all the trees. Folks, I'm standing on the road. That thing's a 15 to 20% slope. How am I going to heal my soil? Covers, crimson clover, vetch, let them heal it. Or I'm going to have to go to a backhoe and just dig up the whole yard. Oh, guess who does not have spring weeds of all the lawns? I don't. Oh, and I saved $150 on lawnmower fuel. See, I tell you, this soil health is getting very, very competitive. Ohio, some of the people in Pennsylvania said, look, man, we can grow them big. In fact, they're so committed in Pennsylvania. Look at this. These guys have the drill waiting, filled with cover crop seed, and they're going on harvesting the soybean, and they have the co-op spraying. Putting their nutrients out there. That's how determined they are. They're so determined they grow them as big as ATVs. North Dakota, the Dakotas, they're growing really big. You guys in the Dakotas, you guys do it all right. But look at the French. The French do this. You know who sent me that? Thomas. You know Thomas Frederick? He goes, you know what? You Americans think you guys, we grow sexy reddish. I said, oh my gosh, Frederick. Okay, we're going to pass this. Folks, I got about 3 more slides, and I'm almost done. Promise. Folks, we are moving to a new type. I'm going to challenge our paradigms, the way we look at nutrient management. Dr. Rick Haney from ARS, soil microbiologist, we are working together. We have a new soil sample new test. And Dr. Ward, we're going to visit, and how for no-till and grazing system. We're going to learn how to teach people how to use these. And the tests are free. You like that? They're free for now. We'll talk about that later. We don't have enough time. It went through Dr. Ward, it went through a 17 peer review. Okay? It bases all this, but I'm going to skip here, but we're going to measure. We'll talk about that later. I got to go. Okay, let's go back up here. Did you see that? I love my cow. That's a high energy using cow. Okay, it's here, folks. We're wrapping it up. Ladies and gentlemen, I am convinced if we make our soils healthy, we can address a lot of our resource issues. We can be prepared for farming for the 21st century. All we got to do is emulate nature. She's been telling us for a long time. The Creator set it up perfect. I have the goal now. And anybody tries to distract me, what's the goal? See, to me, freedom is when you guys aren't dependent on fertilizer, on herbicide. You guys can grow your own fuel. You can get your own seed. You can really be free. But if you focus on bushels, you will never be free. You're looking at the wrong part of the equation. It's the other side of the equation that'll make you truly free. It's the inputs. I no longer sit there and say, oh man, I grew 300 bushel corn. Don't care. Can you grow it at $1.10 a bushel? This is where it's at. Gabe Brown, last slide. Folks, he grows corn at $1.10 a bushel, and he has 159 bushel corn. Burley County, supposed to be 16-inch precept. He's making money. If corn drops down to 3, he's making money. That's what it's about. Because ultimately, that's it. Folks, we have gotten so smart that we become stupid. This came from a picture of National Geographic. Do you remember the Dust Bowl I was showing about 2 months ago? We have not learned our lessons. I go all over the country, and we still have this going on. Think about this. The great technology, our fuel is running out, and we're creating a desert at the same time. We don't have to repeat this. We don't. We have the knowledge. It's about all of us working together as a whole to save our country, and it's not just about our country, it's our planet. And I'm excited because this is growing everywhere. It's growing in France, it's growing in Australia. Soil health is spreading all over the country, and we're all part of it. And I want to thank you for letting me speak to you guys today. We appreciate you guys.